Today we're going to look at the last topic of Unit 5A. I'm going over dividing by square root and trying to get those radical symbols out of your denominator. So as we talk about that, just remember that anytime we have 5 radical 3, that really just means you're multiplying 5 times the square root of 3. So another example is if you had 6 times the square root of 2, really that is the same thing as 6 being multiplied times the square root of 2. So as we get into here, we have two different types of problems we're going to look at. The first is when we just have one term in the denominator. So on the bottom of our fraction, there's just one term. And then the second type of problems we're going to look at is when we have binomials or multiple terms in the denominator. So starting with these problems with one term in the denominator, anytime that you have a radical in your denominator, we can't have radicals in the denominator. So what we're going to do to get rid of that radical is we're going to multiply it by the exact same expression. So here, if we have 5 over square root of 2, what we're going to end up doing is multiplying both the top and bottom by the square root of 2. So we're multiplying by that exact same radical expression. And here we're able to do that because really the square root of 2 divided by the square root of 2. So anything divided by itself is just 1. So here really we're just like multiplying by 1, so we're not really changing the value here. But we're getting rid of this radical symbol in the denominator. So what happens when you multiply the square root of 2 times the square root of 2? Really we talked about it last class, but anytime you're taking a number under the radical symbol, multiplying by that same number under the radical symbol, your answer is just going to end up being that number. So to show you here, really you would have the square root of 2 times 2, which is going to end up being the square root of 4, and we know that the square root of 4 really is just going to be 2. So that is just looking at the bottom of the fraction there. So anytime you're multiplying the square root of 2 times the square root of 2, on the bottom there, that's just going to give you the answer of 2. Up top, remember you can only multiply whole numbers with whole numbers, radicals with radicals. So here, really we just have 5 being multiplied times the square root of 2. So we're just going to leave that as 5 times the square root of 2. And here you see our final answer does not have any radical symbols in the bottom of the fraction. So it's all right to have them up top, but not on the bottom. So our final answer is 5 radical 2 over 2. So remember, you're just going to multiply both the top and bottom by whatever radical you have on the bottom of your fraction. Just quick note, going back to multiplying fractions together, just make sure when you're multiplying fractions together, we're going to multiply just straight across the top, right? So here we just took 5 times the square root of 2 to give us 5 times radical 2. On the bottom, you're just going to multiply across the bottom. So the square root of 2 times the square root of 2 really ends up being the square root of 2 times 2, which is going to take us to our answer of 2. So as we multiply fractions together, just make sure you're multiplying across the top and then across the bottom. So here on our next example, we have 3 over 5 times the radical 3. So what we're going to multiply by is the radical on the bottom. So here we're going to multiply both the top and bottom by the square root of 3. So when we do that on the bottom, we can do the top first actually. So multiplying on the top, whole number 3 times radical 3. Remember, we're not going to multiply those together. That's just going to end up being 3 times the radical 3. On the bottom, when we're multiplying these together, really what we have is 5. And then since we're taking the square root of 3 times the square root of 3, and every time you're taking number under the radical sign, multiplying by the same number under the radical sign, your answer is just going to be the number. So here on the bottom, we're just going to end up with 5 times 3. So when we took radical 3 times radical 3, that answer is just going to be 3. Next, we're just going to multiply those numbers on the bottom. So really our final answer is just going to be 3 times the square root of 3 over, on the bottom, 5 times 3 ends up giving us 15. Let's look at another example. So looking at this example, we have 3 square root of 14 over 2 times the square root of 5. So we always want to multiply by the radical that's on the bottom So here we see that we have the square root of 5 on the bottom, so multiplying both top and bottom by the square root of 5. So let's multiply the top first. Remember, the numbers, whole numbers get multiplied with whole numbers, radicals get multiplied with radicals. So here there's nothing to multiply the 3 by, so 3 is going to stay. But underneath our radical symbol, we're going to multiply the 14 times 5. So 14 times 5 ends up giving us 70. So now as we look at the bottom of our fraction, looking at the denominators, we have nothing to multiply the 2 by, so the 2 is going to stay. And here when you multiply square root of 5 times square root of 5, that's going to end up just being 5. So as we go to simplify this, you want to check to see if that radical expression, so the square root of 70 up top, can be simplified. We'll check that here in a second. But multiply the numbers on the bottom, 2 times 5 gives you 10. So if we're looking at the square root of 70 and you want to see if it gets simplified using our factor tree method, 70 can get broken down into 7 times 10, 10 can get broken down into 5 times 2. All of those are prime numbers, but we don't have any pairs. So that's as simple as that radical can get. So here our final answer would be 3 times the square root of 70 divided by 10. Okay, this last example with our 1 terms in the denominator. This time is a little different because we have multiple terms up in the numerator, right? So we have the 5, and we also have the negative 2 times square root of 3. So what's going to happen is we're going to multiply this always by the radical that's in the denominator. So multiplying both by the square root of 6. So up top, what's going to happen is we want to make sure we take this and we multiply it times both these terms, just like you would if you were distributing. So taking the square root of 6 and multiplying it times the 5 would end up giving us 5 times the square root of 6. And then next, with our distribution, we want to make sure we take the square root of 6, multiply it times negative 2 times square root of 3. So obviously, the negative 2 is going to stay because there's nothing to multiply that by. But then multiplying what's under the radical symbols, 3 times 6 gives us 18. So remember, you're always going to multiply whole numbers with whole numbers, what's under the radical with what's under the radical. So up top, once we've multiplied the top of our fraction by the square root of 6, we have 5 times the square root of 6 minus 2 times the square root of 18. On the bottom, when we multiply the square root of 6 times the square root of 6, our answer is just going to end up being 6. So the next step is to look to see if any of those radicals can be simplified. So the square root of 6 cannot be simplified. The square root of 6 just gets broken down to the prime factors 3 and 2. The square root of 18, though, so if we looked at the square root of 6, that just gets broken down to 3 and 2. The square root of 18 you can break into 9 times 2. 9 can get broken down into 3 times 3. So here we see we have a pair of 3s that we can pull out. So if we pulled out a 3 and moved it to the outside, really the square root of 18 can get broken down into 3 times the square root of 2. So just moving those 3's out front. So this was already, take that back real quick, this was negative 2. So really when we move the 3 out front, we're also going to multiply that times the negative 2 that was already there. So when we do that, we wind up with negative 6 times the square root of 2. So that's going to replace our second term. So going back up top, we said that 5 times the square root of 6 cannot be simplified, but we did simplify negative 2 times the square root of 18 into negative 6 times the square root of 2 all over 6. So what we did here was we just simplified the second part into negative 6 times the square root of 2. So you always want to make sure your radicals are simplified as far as they can go. So anytime you just have one term in the denominator, so looking at these 4 problems, anytime we have one term in the denominator, we're just going to multiply by the radical in the denominator on the top and bottom of our fraction, and then simplify any radicals after that. This next one, we have binomial expressions in our denominator, so we're going to want to multiply by the conjugate of the denominator. So the conjugate just means that we're using the exact same numbers or values, we're just flipping our sign. So on that first example, we have 5 over 1 minus 2. So we're just going to write the same thing on the bottom, except for this time we're going to flip it to be 1 plus the square root of 2. So conjugate just means that you're using the opposite operation. So once again, you want to multiply the top and bottom here. Since we have expressions that are on the bottom, these are really just expressions here. So we're going to multiply by that same expression. We're just going to change the sign. So that is the conjugate there. So the conjugate of 1 minus the square root of 2 would be 1 plus the square root of 2. Remember, anything we multiply on the bottom of our fraction, we also need to multiply up top of our fraction. So what's going to happen is we're multiplying the top and bottom by 1 plus the square root of 2. So let's do the up top first. So up top we're going to have to distribute here. So taking the 5 times the 1 gives us 5. Taking the 5 times the square root of 2 is just going to give us 5 times the square root of 2. On the bottom here, what's nice about using this conjugate is we're going to do the FOIL method. Remember, which is first, outside, inside, last. And when we do that method, this time we'll FOIL it out just to show you that. We're going to be able to take a little bit of a shortcut here in a second. But multiplying our first terms together, so multiplying 1 times 1 would give us 1. Multiplying our outside terms together, 1 times square root of 2 is just going to be the square root of 2. Multiplying our inside terms together, so we have negative square root of 2 times 1. That's going to give us negative square root of 2. And multiplying our last terms together, negative square root of 2 times positive square root of 2 is just going to give us a negative 2. So remember, if you're just multiplying square root times itself, that's just going to end up being the number. So what happens here is our outside terms and our inside terms are always going to end up being opposite once we FOIL, because we're using the conjugate, so it's always the opposite value. So here you see that the outside term is the square root of 2, the inside term is negative square root of 2. So these values are going to end up canceling each other out. And what we're really just going to be left with after multiplying those things is just our 1 and our negative 2. So just the terms that we get from multiplying our first and last terms. So from here on out, we're just going to multiply our first and last terms when it comes to the denominator. Up top, you might still need to FOIL, but when you multiply conjugates together, you really only need to multiply the first and last terms because your outside and inside terms will cancel each other out. So looking to simplify this expression now, we have 5 plus 5 times the square root of 2 up top. And that cannot get simplified anymore, but on the bottom, 1 minus 2 ends up being a negative 1. Really, if we wanted to, we could also just divide each of those terms up top by negative 1. So another way to write that would just be negative 5 minus 5 times the square root of 2. So either way, I would accept. So we have another example. So here we have 3 over 5 plus the square root of 3. So here we're going to multiply by the conjugate. So we're going to multiply by 5 minus the square root of 3 on the top and bottom. So we're just going to take this same numbers, we're just going to change the operation in between. So taking the top now and distributing this 3. So 3 times 5 is 15. 3 times negative square root of 3 is going to be negative 3 square root of 3. On the bottom, remember, we're just going to multiply our first and last terms. So with our conjugates on the bottom, we're just multiplying our first and last terms. So multiplying our first terms together, 5 times 5 is going to give us 25. Multiplying our last terms together, so the second terms, square root of 3 times negative square root of 3 is just going to end up equaling negative 3. So once we subtract those two things that are on the bottom, those like terms, we have 15 times square root of 3 over 22 as our final answer. Looking at this next one now, we're going to get into where we have binomials on the numerator and also the denominator. But the process is going to remain the same. So really what we're going to do is multiply both top and bottom by the conjugate. So the conjugate of the expression on the bottom, 2 plus 3 times the square root of 5, really is just going to be 2 minus 3 times the square root of 5. So we're multiplying that expression times the top and the bottom. So what's going to happen up top is we're going to end up having to FOIL up top. So looking at multiplying our first terms, outside terms, inside terms, and last terms. So multiplying our first terms together up top, positive 3 times positive 2 ends up giving us positive 6. Multiplying our outside terms together, we're taking this positive 3, multiplying it times negative 3 times the square root of 5. So remember, whole numbers get multiplied together, so 3 times negative 3 is negative 9. And we have the square root of 5 under our radical symbol. Multiplying our inside terms together, we have negative square root of 2 times 2. So that's going to give us negative 2 square root of 2. And then the last terms, multiplying our last terms together, we have negative square root of 2 times negative 3 times square root of 5. So remember, negative times negative is going to end up being a positive. And this time, we're going to have the 3. And then multiplying what's under our radical symbols, 2 times 5 gives us 10. So that is the top two binomials multiplied together. So we just use the FOIL method there to come up with those 4 terms. Then looking at those, we want to see if there's any radicals we can simplify. And the 5 can't be simplified. The 2, square root of 2 can't be simplified. And the square root of 10 also cannot be simplified. So that's as simple as they get, and there's no like terms for us to combine. So moving to the bottom. So remember, the bottom is always where you can take the shortcut, right? Because you're multiplying your outside and inside terms there. You see that those are going to be opposite, right? So looking at the outside terms, you have 2 times negative 3 times square root of 5. And then on the inside, you have 2 times positive 3 times square root of 5. So those are opposites. They're going to cancel out. So we're just going to multiply our first and last terms here on the bottom. So 2 times 2 is going to give me 4. And then our last term is positive 3 square root of 5 times negative 3 square root of 5. It's going to be negative 9 times 5. So the square root of 5 times the square root of 5 really is just the square root of 25, which is going to end up being 5. So the key here is we want to do our multiplication first, right? So anytime you have addition, subtraction, multiplication, division, the multiplication and division need to be done first, and then your addition or subtraction. So here you're going to take the negative 9, multiply it times 5 first. So as we go to simplify this, negative 9 times 5 really ends up being negative 45. So we still have our expression 6 minus 9 square root of 5 minus 2 square root of 2 plus 3 square root of 10 up top. And then lastly, we're just going to simplify that bottom of the fraction there. So 6 minus 9 square root of 5 minus 2 square root of 2 plus 3 square root of 10 all over here. 4 minus 45 is going to end up being negative 41. So now we've got then the radical out of the denominator. So we have 6 minus 9 times square root of 5 minus 2 times square root of 2 plus 3 times square root of 10 all over negative 41. Or if you prefer to write the negative sign out front, we prefer to write the negative sign out front instead of having it in your denominator. You can also write that. So that 41 is on the bottom, you throw the negative sign out front there. Those two things are the same. One, you're just putting your negative sign out front of the fraction. The other, you're just leaving it in your denominator. So let's look at this last example here. So again, this last example. We're taking, erase some of this. So again, this last example here, we have 5 minus Square root of 6. So we're multiplying by both sides by 5 plus the square root of 6. So multiplying those two things together. We're going to up top, make sure we FOIL. On the bottom, we can take a little shortcut and just multiply our first and last terms. So FOILing up top, multiplying our first terms together. 1 times 5 up top, so the two terms that are first in the parentheses. 1 times 5 is going to give us 5. Our terms on the outside, so 1 times square root of 6 is just going to end up being the square root of 6. Your inside terms together. Negative 2 times square root of 6 times 5. So multiplying our whole numbers together, we get negative 10 square root of 6. And multiplying your last terms together. Negative 2 square root of 6 times square root of 6 really ends up just going to be negative 2 times 6, which is going to change to negative 12. So looking now at the bottom, remember we're just multiplying our first terms and our last terms, so 5 times 5 is 25. And then the last term's negative square root of 6 times positive square root of 6 is going to end up giving you a negative 6. Looking to combine our like terms and simplify. Up top, you see that we have the 5 and the negative 12 that can be combined to make negative 7. We also have two like terms as far as these radical 6 terms. So if we had 1 square root of 6 and we subtracted 10 square root of 6, that would take us to negative 9 square root of 6. On the bottom, 25 minus 6 ends up being 19. There we just had to do the same thing we did in the previous problem, except for this time after FOILing up top, there were some like terms that we could combine. So the 5 and the negative 12 we combined to make negative 7. Square root of 6 and negative 10 times square root of 6 we combined to make negative 9 times square root of 6. Now let's see, we're going to simplify the denominator there. 25 minus 6 gives us 19. The biggest thing here with our binomials expressions, so these last 4 problems, is we're multiplying both top and bottom by the conjugate. So the conjugate just means you're using the same numbers but changing your sign. So if it was addition, you're going to change it to subtraction. If it was subtraction, you would change it to addition. So on the bottom, since we're multiplying by the conjugates, when you're doing the denominators, multiplying those together, you can just skip the outside and inside terms, so you're just multiplying your first terms together and then your last terms together. But up top, make sure you distribute or do the whole FOIL method up top.